Hey guys, welcome to my channel. I'm LeetCoder, and today we have an amazing problem for you guys. So let's quickly go ahead and read it real quick, guys, right? So the problem's called interval list intersection, right? We're given two lists of closed intervals, right? First list and second list, right? Where first list of I, right? Every index. We have two pieces of data, right? Which is a start and an end, right? I'm saying so the first index is start and the second index is end, right? And it's the same for the second list, right? It says each list of intervals, right, is a pairwise disjoint, and in sorted order, right? So okay. It says return the intersection of these two interval lists, right? That's the ask, right? It says a closed interval, right? A to B, right, is where A is less than or equal to B. It denotes the set of real numbers X, right? With A being less than or equal to X and X being less than or equal to B, right? The intersection of two closed intervals is a set of real numbers that are empty or represented as closed interval. For example, the intersection of 1, 3, and 2 and 4, right, is 2 and 3, right? Because, guys, right, those two different intervals, right, there's an overlap, right? So the intersection between those two sets, or I'm saying ranges, right, is obviously 2 and 3, guys, right? Because I'm saying 2 fits inside of this range, right? 2 and 3. And then 3, they pretty much, we only care about the intersection, the part where they pretty much overlap, right? You know what I'm saying? That's kind of, yeah, for me, that kind of makes sense, right? So I think that the examples will make it a lot more clear to you guys, right? What the ask is for. So we got our first list, we've got our second list, right? And then we get the representation of those two lists right there, guys, right? So what we're doing, right, is so given those two lists, right, we need to find the intersection, right? I'm saying between them, right? So for this one, you can see down I'm saying, so the first one, this one overlaps with this one, right? Because, guys, right, this one started before this one ended, right? So there's an overlap between them, right? So we're kind of already used to overlapping intervals because we've done several problems on this channel that involves intervals, right? I'm saying we see that there's a overlap, right? So normally we would merge them right together, right? I'm saying, but this time we're not doing that, guys. We are simply um capturing, right, the part where they overlap specifically, right? So where they overlap, that's where we're going to um pretty much record, right? So that's what's going on right there. So this part, that's where the overlap, right? That's where we store it as in the our answer right there, right? And then the overlap right here as well, right? And we store it right there. So that's 1, right? So we got 5 and 5 right there, right? That's the part where they overlap, right? And there's an overlap right there as well between this one and right there, and the overlap, right? And so on and so forth, guys, right? And they got this one as well, right? We're giving 1, 3, 5, 9, and the second list is empty, right? So we return an empty list, I'm saying. All right, so yeah. Also, how do we go about solving this problem, right? So this is what we'll be going into in my whiteboard, right? So let me just go to it real quick, and hopefully I could clear any doubts, right? So yeah, guys. So right now we see that when we're given two lists, right? The intersection. We only want to store the intersection between those two, right? So by storing that, guys, right, we are able to get the intersection as we want, right? So how they did derive at that, right? I'm saying visually we could do it, right? How do we put it into code, right? So that the machine can also find it for us, right? The intersection, right? Between two lists. Visually looking at it, we could easily see it, right? I'm saying, boom, and this is where they overlap right there, right? Right there, boom. I store them right there, boom. That's another overlap. Forget to record, right? Which is only this one, right? Just draw out here real quick. All right. Signify, right? And then those two overlap, right? That's why we put it right there. Right there, you guys, right? And this is obviously another overlap right there, you know what I'm saying? And then another overlap between those two, right? And see this one, right? That's why we store them right there, guys. So see, by just doing it regularly, we could easily find it, right? So what kind of logic do we need, right? How is our algorithm gonna work, right? So that's kind of what we need to do right now, right? Um, So when they overlap, right, is when, like, there's kind of visually we can see it. So they overlap when, guys, right, when there's and one of the intervals, right, fit inside of another interval, right? I'm saying we can kind of see that visually easily. So in code, guys, we see that normally we when in so when we have one interval, right, and we have another interval, right, the first interval, let's say there's a lot of different scenarios that can happen in overlapping, right? I'm saying this one we for this particular one, right, we see that um the second interval, right, you know what I'm saying, started before the first interval ended, right? So that's how we're able to know, this is obviously this overlaps, right? This is the logic that we use in the other problems that we have done, right? So for this problem, right, to find out the only the overlapping part, right, we kind of have to do a little bit of the same thing, guys, right? So to only capture uh the overlapping part, guys, right, the intersection between those two intervals, right, what we need to do, guys, right, what we were doing, guys, you see how for any interval, right, we were choosing, guys, right? If we're choosing the maximum, right, start time of whatever two intervals that I'm comparing, you know what I'm saying? We choose the maximum start time, right? And then we also choose the minimum end time, guys, right? Right? So by doing that, guys, we are producing the strict, I'm saying, intersection that's required for us to return, guys, between any two intervals, right? So, right. So say we got one interval and one interval, like, started in between it, right? Which is the case here, right? You know what I'm saying? So that means that the second interval started like later, right? Then I started, right? So the intersection the is gonna happen starting at when the second interval started, right? And when whichever one of the two, right, ended first. I'm saying this is where the intersection between the two intervals is gonna reside, right? So this is why we have that. Um, we choose the minimum out of the two intervals, right? I'm saying the minimum one out of the two intervals, right? The end time, the minimum one, right? So as soon as one of them closes, right, this is the intersection between the two, right? Which is exactly what we did there, guys, right? We chose the minimum end time, which was A, right? Which ended earliest, right? And that's why we captured that, you know what I'm saying? We captured it and then we recorded, right? And if you look at it, we do the same thing for all of them, right? I'm saying so then this one is another example, right? We see that this one's going, you know what I'm saying? But yet this one started in the middle of that range, right? So because of that, right, we chose that maximum. So the maximum start time out of the two obviously is 8, right? That's why we started our intersection at 8. And then we chose the minimum end time out of the two, guys, right? Which was this one ended the soonest, right? So we captured it right there, guys, right? That's how we were ended up with that, guys. That's kind of the main point, the main logic that you need to understand. That's how we were able to capture all of the other um intervals, right? The intersection between them, right? So hopefully that kind of made sense, guys. So let's quickly go ahead into the code, right? So pretty much the two main takeaway is the intersection, I'm saying, is to pick the maximum start time and uh pick the minimum end time out of the two intervals, right? I'm saying. And this is gonna pretty much help you in capturing the minimum, right? I'm saying. So let's say, guys, where we have something like that, right? So we got one, so 1, 2, 3. And the second interval was like let's say it was from 4 4 to 6, right? Let's say that, right? Okay. So 46. So now we were converting to 2, right? So choosing the minimum out of the two, right, would be the maximum start time out of the two intervals that you're comparing, right? So would give you what, guys? Would give you the maximum one would be 4, obviously, right? And then we choose the minimum out of the two endpoints, right? I'm saying for any two intervals that we're comparing, this is the exact same thing that we'll be doing, guys, right? So obviously the minimum one is 3, right? You know what I'm saying? So to see that, so now we chose the maximum start time, right? Right. And this is our end time, right? So we do a comparison, right? If the start time, right, is less than or equal to the end time, right? That means that this interval, right, that we've captured, I'm saying, is a valid interval. It's a valid intersection between the two intervals that we're comparing, right? If that's not the case, guy, which is not the case here, right? I'm saying because 4 is not less than or equal to 3, right? So therefore, there's no overlap between the two, right? So let's say, just let's say, all right, just for argument's sake, right? All right, say it started from start with 2, right? Then this thing will change, right? If you think about it. I'm just right. It'll be a little bit different, guys, right? So the the maximum start time between the two will be 2, right? And the minimum end time between the two would be 3, guys, right? And this fit our condition, right? So therefore we would have uh those two intervals, this interval I'm saying is the overlapping part, right? Pretty much. This is a valid one, right? Because start is less than or equal to end, right? So this is what we would capture, right? Which is the overlapping part, guys, that they have together, right? So hopefully the thing kind of makes sense. Let's quickly go ahead into the code, guys, right? Hopefully everything kind of makes sense, right? So to what we're gonna have to do, guys, right? You know, we're gonna have to pretty much have a two uh pointers to iterate through to, right? You know what I'm saying? Because we have two lists, right? Because then we're gonna be doing the comparison, right? And then we're gonna be incrementing our indexes, I'm saying, our pointers to go to other intervals so we could pretty much do the comparison between the two lists of intervals, right? You know what I'm saying? They're not together, right? I'm saying. Uh yeah. And it's not like we're gonna be merging them into what I'm saying, like merge them into one list before we start doing any trying to find any intersection, right? It wouldn't make sense for this problem anyway, you know what I'm saying? So we need an output list, right, to pretty much return the results to the caller, guys, right, which is very, very important, right? We have our while loop, right? It's pretty much this is what we're gonna use to pretty much iterate through, right? So before we do that, I'm gonna have pretty much store the first lists, right? Call it M. Let's call it second list. I'm just storing the length of those lists, guys, right? Because we're gonna have a condition that's gonna pretty much balance, right? So I spelled them right. That's pretty good. While I is less than n, right? And j is less than or equal to n, right? We're gonna do it in start, right? So now this is what we're gonna use to iterate, right? So now I'm gonna check, right? This is what I'm doing. I'm comparing the intervals together, right? They're sorted and all of that, right? So that's a pretty good thing that they did for us, right? They give it us as input. They're already sorted, you know what I'm saying? So we could do the comparison one by one, right? And then move along as needed, guys, right? So the condition is while we're iterating through both lists at the same time, right? We're going to so we have the condition to pretty much while we're in bounds, right? So that's pretty important, right? So so we're gonna pretty much do some kind of like comparison, right? So we're gonna choose, remember the logic that I told you guys, right? I'm saying we're gonna try to pretty much see if there's any overlap, right? This is exactly what I'm doing right there, right? So I choose for any two variables I'm comparing, right? I do the exact same thing, guys, right? Remember to sort it, right? I'm saying so if there's any overlap, I'm going to find it because I'm saying we're going into an assorted manner, right? So we have our first list, right? The I is gonna help us to iterate through the first list, right? And we have our J that's gonna iterate through the second list, right? I'm saying, don't worry, I saw it, J, right? So we choose the maximum one out of the two, guys, right? And then what we're gonna do, I told you guys, right, how to find the end time. We find the So we get the minimum one, right? Which the one that ended the earliest, right? That's gonna yield us the max the intersection that we're looking for. So we'll do a simple check right there, guys. If this is a valid interval, right? This is a valid one, right? We're gonna pretty much add it to our output thing that we have, guys, right? So we add it, we store it, right? So this is one intersection, one valid, I'm saying, interval that, I'm saying, overlap, right? So now the next thing that I'm about to do is simply to so we need to know which pointer do we move forward, right? You know what I'm saying? Because we are iterating through and finding, you know what I'm saying, the different like, intersections, right? So we need to know which pointer to move first, right? So logically, we would choose, right? So if the first interval ended earlier than the second interval, right? Then obviously I better off moving the first pointer to onto the next one, right? I'm saying because the second list might overlap with other intervals, right? I'm saying that's why I move the first interval rather than the second one, right? So that's kind of the logic there, guys, right? And kind of makes sense if you kind of think about it a little bit, okay? So I'm gonna do if the first list, right? If it ends, right, before the second list, right? If it does, right, then I move the that pointer to go forward, right, in the first list, right? If that's not the case, then I move the second pointer to go on to the next one, right? And yeah, after I do that, I simply return res that to array, right? See what they're asking for, and I'm returning that. I'm returning the output, right? So res that size. Looks good so far. Like I said, just quick recap. We got our pointers, right, to iterate through both of the list, right? Then we got our output result, and we took the length, right? And then we are iterating through both lists, right, at the same time. And we pretty much check every time for any overlap between the two intervals that we are iterating through, right? And we choose the maximum start time, right? What I'm saying, and we choose the minimum end time between any two, right? And then we do that, and then we move forward depending on which one ends the soonest, right? Let's press run code to see if we pass any test cases. Let's press submit. Awesome, guys. We're able to pass all the test cases, guys. I want to thank you guys for watching this video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So thank you guys for watching, and I'll see you guys in the next one.